In this lesson, we're going to talk about how to go from a graph to an equation rather than an equation to a graph. So, as it says here, so far we've talked about how to sketch the graph when we're given an equation. Now we're going to talk about going the other way. So suppose we're asked to determine the equation of the sinusoidal curve that you see at the right. Well, first thing we want to do is establish that the parent function is y equals negative cos x. You might recall that y equals sine x looks like this, y equals negative sine x looks like this, y equals cos x looks like this, and y equals negative cos x looks like this. So we see that the curve we have is most accurately thought of as a y equals negative cos x curve. Then we see the phase shift is 2 squares to the right. So our phase shift is 2 to the right. You might be tempted to say d is 2. But at this point, you want to look at the index there, or what we sometimes call the scale. The scale of the x-axis is that every square is equal to pi over 5. So if d is equal to 2 of those squares, then really d is equal to 2 pi over 5. Okay, so the phase shift is 2 pi over 5 radians to the right, meaning d is 2 pi over 5. Now, one entire cycle is 8 squares long. The whole horizontal length of that cycle from bottom to bottom, from the minimum point of the cycle to the minimum point of the cycle, is 8 squares. So you might be tempted to say, okay, well, our period is 8. But remember, each one of those squares represents pi over 5 horizontally. So really, the period is 8 pi over 5. Okay? Now, sometimes students make the mistake of saying the period is 10 because they count from the y-axis to the end of the first cycle. But that's not actually the way to do it, because this part isn't actually part of the cycle. The cycle is starting 2 squares to the right of the y-axis and ending 10 squares to the right of the y-axis. So it's this horizontal distance that we're looking at, which is 8 squares. Okay, so the period's 8 pi over 5. Now, we know that the period is always equal to 2 pi over the absolute value of k. That means that the absolute value of k is equal to 2 pi over the period. Now, in this course, we can assume the k value is always going to be positive in this type of a question. So we can say that k is equal to 2 pi over the period. Well, the period is 8 pi over 5. So what we do is we invert the denominator and multiply, and we end up being able to say that k is 10 pi over 8 pi. Of course, the pi's cancel out, and we have 10 over 8, which can be reduced to 5 over 4. So we know our d value and we know our k value. Now, we look at this whole cycle and we say, okay, that whole cycle is 4 squares high, but the axis of symmetry is halfway in between. So the axis of symmetry is actually at y equals 3, because the curve will be above, goes 2 squares above y equals 3 and goes 2 squares below y equals 3. Okay, so we can say that the c value, which is always the y value of the axis of symmetry, is equal to 3. Some students are going to get that by observation, but maybe you like formulas. If you like formulas, then here's a formula for you. The formula to determine c is that c is equal to the maximum y value plus the minimum y value all over 2. Well, the maximum y value is equal to 5, the minimum y value is equal to 1, and so we can say 5 plus 1 over 2 equals 3. So that'll always be the c value. And we also want to know the amplitude. Well, the amplitude is going to be the distance from the axis of symmetry up to the maximum point or down to the minimum point. Either one is good. So we can say the amplitude is 2. And a lot of students will get that by observation, but some of you are going to prefer formulas. So if you prefer a formula, it'll always be equal to the maximum y value minus the minimum y value over 2. Again, the maximum y value is 5 and the minimum y value is 1. 5 minus 1, quantity divided by 2 is equal to 2. So there's our amplitude. But you might want to also remember that we have a parent function of negative cos. So since we have a parent function of a negative cos curve, and since our amplitude is equal to 2, we're going to put a negative 2 in front. Okay? Now, because A is going to equal negative 2, amplitude is equal to positive 2. Okay, so we know that the equation of this curve will be a cos x minus d, a cos k times x minus d plus c. Well, we again have an amplitude of 2, but since the parent function is negative cos, we say that a is equal to negative 2. And then our k value was evaluated earlier to be 5/4. D was evaluated earlier to be 2 pi over 5. We're using radians here because radians are used in the index on the x-axis. And finally, our c value was 3. So that's the equation of the curve. Now, it is possible to state each of those curves, negative cos curve as a positive cos curve or positive sine curve or negative sine curve. And a lot of times what you'll do is you'll just go by what the question gives you and ask yourself which one's the most convenient. So now we look at the curve given here in our second example. And we remember our 4 parent functions. We have a positive sine curve, we have a negative sine curve, we have a positive cos curve, and we have a negative cos curve. Okay, so looking at this graph given here on the right hand side, we see that it most closely resembles a positive sine curve. So our parent function is going to be y equals sine x. Then we're going to see the phase shift is 1 square to the left. So we might be tempted to say d is negative 1. But remember, the index is 20 degrees. So every 1 square is equal to 20 degrees. So what we do is we say d is equal to negative 20 degrees. Okay? And that's how we get that value down there. Now, the entire horizontal distance of one cycle is going to be 12 squares. So what we see here is from the start of the cycle all the way to the end of the cycle, it's 12 squares. You might be tempted to say the period is equal to 12, but remember we have to multiply by the index, which is 20 degrees, to say that the period's really 240 degrees. Now, we can say that we know the period is equal to 360 degrees over the absolute value of k. Rearranging that equation gives us that k is equal to 360 degrees over, the absolute value of k is equal to 360 degrees over the period. In this course, you can assume k is going to be positive in this type of a question where you're coming up with the equation yourself. So we can say that k is equal to 360 over 240 degrees. The degree symbols cancel out. 360 over 240 reduces to 3 over 2. Now, the entire curve from maximum to minimum is 6 squares high, meaning the amplitude is going to be 3, and the axis of symmetry is going to be at y equals negative 4. And some students can see that from observation. They can tell where the axis of symmetry is, and then they can count the squares up or count the squares down. But if you prefer formulas, then use a formula. C will always equal the maximum y value plus the minimum y value over 2. So negative 1 added to negative 7 divided by 2 is negative 4. So the C value is negative 4 because the axis of symmetry is at y equals negative 4. And we want to also know the amplitude. Well, a lot of you are going to be able to tell by observation that the amplitude of this curve is 3. It says negative 4 here, but it should say 3. That's a typo. So you're going to be able to see the amplitude is equal to 3. But if you can't see that by observation, just use the formula. That always works. Amplitude is always equal to maximum y value minus minimum y value all over 2. The amplitude is 3. Now, since we're using a positive sine curve with an amplitude of 3, we can say that A is actually equal to 3. Okay, So A won't always equal the amplitude. A will sometimes be negative of the amplitude, but that will only happen if you're using a negative sine curve or negative cos curve as your parent. If you're using a positive sine curve or positive cos curve as your parent, A will just equal whatever the amplitude is. So we can say that y, we said our parent function was sine x, so that's why we have that. So y is equal to a sine k x minus d plus c. Okay, now why don't we do another question here? Determine the equation of this curve. Well, if you want to know the equation of that curve right there, first thing you might say is that looks like more than one cycle. And you're right, it is more than one cycle. And if we want, we can think of this as a negative sine curve. Everything I've just colored in red would make it one cycle of a negative sine curve. Or you might say, you know what, I would prefer, oh, sorry, yeah, negative sine curve. Or you might say, okay, sir, instead of that, I'd prefer to think of it as a negative cos curve. And you'd be right if you did that too. So you see you have options. If you think of it as a negative sine curve, you'll have a phase shift that's different than if you think of it as a negative cos curve. So there's going to be different answers to this type of a question on a test depending on how you look at it. But the way I look at a question like this, and you might choose to look at it this way as well, is I say, you know what, perhaps the easiest sinusoidal function cycle to recognize is a positive cos curve or a negative cos curve. A positive cos curve just goes from the maximum point up to the next maximum. So you can kind of see one. And a negative cos curve just goes from a minimum to the next minimum. So you can kind of see those easier. So generally speaking, in a question like this, that's what I look for. So let's focus on the first positive cos curve that we see there. Okay, so this, what you see in green, is one cycle of a positive cos curve. Okay, now when we look at that, we say to ourselves, okay, our phase shift is 2 squares to the right. So d, you might be tempted to say d is 2, but each one of those squares represents 3 pi radians. So really, d is equal to 6 pi, okay? And so we've got our phase shift, which gives us our d value. Now, our period, you might look at this, and you don't want to count the entire horizontal distance of what you were given. That's not the period. The period is equal to the horizontal distance of one cycle. So the period is just equal to the horizontal distance bolded in there. And that is 4 squares. So you might be tempted to say, okay, therefore the period is 4. But remember, each one of those squares is 3 pi radians because that's the scale given on the x-axis. So the period is really going to be 12 pi. Okay? Now the k value, we know that the k is always going to be positive for this type of a question in this course. We can choose to make it positive. And if you're curious why we can do that, we're accounting for that, whether the k is positive or negative, when we choose our parent function and our phase shift. But for our purposes, we can say k is just equal to 2 pi over the period. Well, we just established that the period is 12 pi. 2 pi over 12 pi is equal to 1/6. So now we know our k value. And we also want to know what our amplitude is. And here's a little side note. Up until now, in the first two questions we had, the scale on the y-axis was always 1. But now we see the scale on the y-axis is 5. So each one of those vertical squares represents 5 vertical units. So we can see that our axis of symmetry will be at the maximum y value plus the minimum y value all over 2, which is -5. And our amplitude will be at the maximum y value minus the minimum y value all over 2, which would make it 15. So putting all of that together, we have an amplitude of 15 using a positive cos curve, so therefore A will be 15. We can say that our equation of that curve is given right here. Now, if you choose to think of this as a negative cos curve or a negative sine curve or a positive sine curve, you'll have the same K value, the same A value, and the same C value. What'll change is the phase shift, depending on how you see it, depending on which parent function you use. Okay. And I'm not sure, we won't have, depending on how you see it, if you see it as a negative cos curve or a negative sine curve, the A value will be negative, but you'll have the same amplitude. Okay, now finally, let's do another question here. Suppose you're asked to sort of construct a curve on your own. So we're told here the point -5/8 is on the axis of symmetry of a sinusoidal function, and the function goes down from -5/8 to the next minimum point at 4, -1. And we want to know an equation of the curve. So we can start by drawing what we know. If we're on the axis of symmetry at -5/8 and we go down to the next minimum at 4, -1, the curve will look something like that. Well, we're given 2 key points here, so there's going to be 3 more. Now, if one of the key points is -5/8 and the next key point is 4, -1, that means that the distance from the first key point to the second key point horizontally is 9. Well, that's going to tell us what our key interval is. And so that's going to tell us that the x value of our next key point will be 13, because if we simply add 9 to here, our next x value will be 13. And we know our next y value will have to be the same as that y value right there, so our next y value is going to be 8. Okay? Then we can say, well, if it looks like we can tell we're coming with a negative sine curve because we're starting on the axis of symmetry and going down. That's what negative sine curves do. So our next key point will be up here. Now the key interval is 9, so in order to get to that next point, we're going to have to add 9 to the x coordinate to get the next key point, and we're also going to have to coincidentally add 9 to the next y coordinate, because we can tell now we're going up or down by 9, because we went from a y value of 8 down to a y value of -1, from a y value of -1 up to a y value of 8. Those are vertical steps of 9. So our next vertical step will be 9, and that'll get us up to 2217. Okay? And finally, we want to come back down again to our axis of symmetry, and we can see adding 9 to our x coordinate, we'll have an x coordinate of 31, and of course our y coordinate will be back on the axis of symmetry, so our next y coordinate will be at 8. So we've drawn one cycle, and now we can just go about figuring out the equation of the curve. We're going to think of this as a negative sine curve, because we're on the axis of symmetry heading down to start. So our amplitude is going to be equal to the maximum y value minus the minimum y value, quantity divided by 2. So 17 minus -1 all over 2 is equal to 9. Our axis of symmetry is at 8. If we want to calculate it, we can say it's the maximum y value plus the minimum y value all over 2. So that gives us 8. Our phase shift is -5. It's 5 units to the left, so it's -5. And our period, the horizontal distance of a complete cycle, is equal to 36. Now, we can state this equation in degrees if we wish. It's not entirely clear from the question, so if we state it in degrees, k will be equal to 360 over the period, which will be 10. If we state it in radians, k will be equal to 2 pi over 36, which will be pi over 18. So we have an option to state the equation in degrees, as shown here up top, and we have also an option to state the equation in radians down below, as shown there.